All right, so this is part 2 of 9.2. Yesterday we started talking about elimination, which was the second of the 3 methods you're going to use to solve systems. Today we're going to finish those examples, and then we're going to get into graphing, which is the third of the methods. So we skipped number 6 yesterday. When I look at 6, the goal is to cancel out either the x's or the y's. So this one I have to change both for the x and for the y, and there's not an opposite sign, which I said to look for yesterday. So really it doesn't matter. Pick one variable, x or y. X, okay? So in the top we want to multiply by 2, which means in the bottom we'd have to do -3. Good. So then I'd multiply that 2 and I'd get 6x plus 4y equals 14. And in the bottom, you'd get -6x minus 15y equals -3. Don't forget to go all the way across to the equal sign to get to the last term. Now, when we add, the 6x and -6x are going to cancel out, which was our goal. And I get -11y equals 11. Divide both sides by that -11. And y equals -1. So then I've got to take that and plug it back in, and you could plug it back into either beginning one or even the one you changed, but obviously it's easier to go back to the beginning. So if I just grab the bottom one and I did 2x plus 5 times -1 equals 1, I'd end up with 2x minus 5 equals 1. 2x would equal 6. Divide both sides by 2, and x is 3. 3, -1 would be the solution to the system. Questions on that one? All right, go to the next slide. So we skipped 9 and 10 on these. You guys go ahead and work through those too. 9 and 10. All right, for 9, I would assume we multiplied the top by 2. So in doing so, you end up with 2x minus 10y equals 6. And when you combine these, the left side cancels. So I get 0 on that side of the equal sign and then 11 on the other side. Not a true statement, so this would be no solution. Remember, if it's a true statement, all real numbers, false statement, no solution. For 10... same thing, if you multiply the top by 2, well, I'd have to do -2. I get -4x plus 2y equals -2. Both of these cancel, and I get 0, and 2 and -2, which is also 0. This time, that's a true statement, so it's all real numbers. Questions on either of those? Raise your hand if you got both right. Okay, good. All right, so today's is the last of the 3 methods that we're going to use to solve a systems of equation, and this method is graphing. So the solution of a system of an equation can sometimes be found by graphing both the equations in the same rectangular coordinate system. The coordinates of the point of intersection give the system solution. So we use these already to check, like we did our graphing calculator to check these. But you won't have a graphing utility when you get these questions on your test. So you'll learn how to graph these things, review how to graph these things by hand, and then identify where they intersect. If there's no intersection, so for example, if they were parallel lines, or if it was a parabola pointing one way and a line going the other way, something like that, then there's no solution. And if the entire graph overlaps, if you end up with the same exact equation, then the solution is all real numbers. So just like everything else, there could be special cases. All right, so these say solve the system by graphing. These are all lines, right? But you could also get parabolas mixed in. So these are lines. We're going to graph them separately, and then where they overlap will be your answer. So go to 12. There's a couple different ways to graph. You could have used your intercepts, or most commonly, we put this into slope-intercept form, or y equals mx plus b, and we're going to graph it. So I'm going to solve for y. So I'd get -y equals -2x plus 3, and then divide everything by -3. And I get y equals 2/3 x minus 1. That's the first one. So solving for y. The second one, I'm going to do the same thing, solve for y. So 6y equals positive 4x, because I'd have to add it, plus 6, divide everything by 6, and y equals 2/3 x plus 1. Now we graph. So I'm going to start with the blue one just because that's what my pen color is right now. I'm going to graph this one first. Starting at +1 on your y-intercept, or on your y-axis, and then using the slope, which is 2/3, up 2 and to the right 3, and do it again, just so you can get a nice straight line. And there's that one. Then, yep. Okay, then I do the other one. So I'm doing the purple one now. I start at -1, and my slope is 2/3, so I go up 2 and to the right 3, up 2 and to the right 3. And I draw that line. And what's happening here? What's true about their parallel lines, right? Are parallel lines ever going to intersect? No, so this would be no solution. Okay, which you could have also identified from here, because if you look at their slopes, they are the same. So if the slopes are the same but the y-intercepts are different, then it's the no solution because it'd be parallel. If the slopes were the same and the y-intercept was the same, now it's all real numbers because they'd be the same line. All right, go to 13. So same thing. I'm going to isolate the y in both the top and the bottom. So I'd get -3y equals -2x plus 3. Divide everything by -3. Y equals 2/3 x minus 1. And then x plus 2y equals 5. So 2y would equal -x plus 5. Divide by 2. And y equals -1/2 x plus 5/2. I'm going to eventually have to get that into mixed number format, so you could do it now if you want, because we're going to have to plot it like that. 5/2 would be 2 1/2. All right, so I'm going to plot them. Again, I'm starting with the blue just because that's what the color I just finished. So 2 1/2 is your y-intercept. And your slope is down 1 and to the right 2. And then the other one starting at -1, and my slope is up 2 and over 3. And it overlaps right there, and that corner point would be 3, 1. Now there was a half in there, right? So if you're not exact, it might not overlap exactly the way you need to. How could you determine if you got the right answer? How could you check that solution? Good. So if you didn't get it exact, or you know you're close but maybe you're not 100% sure, you could take this value and you could plug it back into either equation, both equations, and make sure it works. So if I got 2 times 3 minus 3 times 1, does it equal 3? This is 6 minus 3, which is 3. So it works in that one. And then in the bottom one, I would do 3 plus 2 times 1, and 3 plus 2 is 5, so that one also works. So if it's a nice, obvious whole number, it crosses right exactly where it looks like it's supposed to, then you're fine. You'd only have to check if you wanted to. But in a scenario in which you're like this one, where our y-intercept was a half, so it wasn't exact on the line, my advice would be just to make sure that that coordinate point works. So that's how we could check to be sure. Questions on that one? All right, go to 14. So I'm going to start with the top. I'm going to solve this one for y. Negative 3y would equal negative 2x plus 3. And then divide by negative 3. Y equals 2/3 x minus 1. Because I'm moving it to the other side, like this one came over here. That's the first one. Second one, 6y would equal, I'd be adding the 4x. So 4x minus 6, and then divide both sides by 6. Y equals 2/3 x minus 1. Now, what do you notice about your two equations? They're the same. What's going to happen when I graph them? Completely overlap, which means all real numbers. So if I wanted to graph one, I could, but they're going to be the same. Amanda. God bless you. So if it says graph and solve, then you want to include the graph. If it was just a solve question, then you don't need it. Yeah. So again, just like the other ones, you can use a graphing utility to check these. You already solved for y, so that step's already done for you. That's the easy part, okay? You feel free to do that to check your answers, but remember that on your test, you will not have your graphing utility, so don't fall back on it as a crutch. You need to be able to graph these by hand. So the questions on the homework that say to graph, not the ones that say to graph to check, but the ones that say to graph or solve by graphing. You need to make sure you include those hand-drawn, not like a picture of your graphing utility, but the hand-drawn graphs in your work. On the homework for the graphing ones, there's a question that asks if it's consistent or inconsistent. So inconsistent means no solution. So if you had a no solution, you would pick inconsistent. If not, you're picking consistent.